Hello. So this video is just designed to help explain how the 3D simulation was made to model what we see in the SCU UFO video. The 3D simulation was built using Maxon Cinema 4D software, using the Cinema 4D Studio package. And I also used a plugin for Cinema 4D that's called Dim Earth. And Dim Earth is designed to model using digital elevation maps, to model geometry that you would see in any sort of application where you needed a map and you needed very precise topology for that map. So that was used to make our 3D model. Let me just briefly kind of show you how Dim Earth works. So you start off with a Dim Earth object, and a default object comes in to begin with, and the default object is set up. If you look here, you can see that it uses the same GPS coordinates as the data that we see in the UFO video. So I thought, by seeing this, that perhaps we could use Dim Earth for the application of building a map of the area that is that we see in that video. And it turned out to work pretty well. So Dim Earth, at any rate, it opens on this default area, which is here on Earth. I don't even know where that is. And then you can also, the other great thing is that you can then take objects and place them also anywhere on the map using GPS coordinates. We leveraged that ability to make the simulation. So anytime you put in any of these GPS marks, you can get a precise location on the map of a particular object. Additionally, Dim Earth will take from various sources. It will load in satellite data so that you can texture the map. So here I'll download some data from Google, and you can also make that texture quality at various amounts of quality. So here I'll download now some more. This will take a moment to download this higher quality texture, but it goes online, it downloads the texture, and then it maps it onto the digital elevation map. So here you see we got much better texture, and then when you render it, it looks even better. So that is that's Dim Earth, and that's what we use to make the model for the Puerto Rico UFO video. And let me show you that. So these textures have to load. Now I had to do a very large area, and although I did download at high quality, a lot of this stuff is it's taken sort of in a mosaic way, so that's why you see the sort of the varying lighting and so forth. But it works pretty well for our purposes. And the way I built it was in this center area, I downloaded much higher resolution imagery for that, and then less so outside, because we don't even really see most of this outside area. But this is a fairly large portion of Puerto Rico and the airport that was involved in the video. And as you know, or as you may know, the video has lots of data on it, but in particular it's got two bits of GPS data, one of which is the location of the plane. And it can tell us exactly where the plane was located at any time during that video, 30 frames per second. Now, I decided to, in order to make this not take as long to make, I decided to only use 1 bit of data per second. But that allowed me to, just as I showed you those little pinpoints, I could place those pinpoints using GPS and get the exact location of the plane, and then put a camera in that location. That's what I've done here. Here's the camera, and I've locked this up to the same frame numbers that we see in the video, so that when I scroll forward, you can see that's exactly where the plane was. I did the same thing using the LOS data, the line of sight data. So that tells us where the camera was looking during that time. So I modeled using, again, one data point per second. I made it so that the camera always looked at that particular point. So that's what you see here. So as the camera moves, it's always looking in the same place that it was looking in the video. So that's the basic idea of how the main simulation was made. And really, that's about it. We also had some information as to the altitude of the camera. That was programmed into the simulation. So that put the, let me see if I can, whoops. There we go. So you can see as I pan around here, the camera's up in the air as it moves around, and it's looking down at the ground as it goes through time. Now let me show you the other thing we did was we decided upon a path, because what was noticed was that no matter what, the lines of convergence of where the plane was looking during its flight all seemed to be focused in this little area right here. Could have been anywhere on the map, but it always seems to be pointing in this area. It starts out here and then it kind of drifts down this way. But that is, we noticed that. So we postulated that what if something that was moving, maybe being carried by the wind, was positioned in that area, in the same area where all the lines of convergence from where the airplane was looking all converge on that one little space. So one of our members modeled a path, and this is the path. I hope you can see it there. It's right there. Let me see if I can make the color different. I'll make it red so you can see it a little better, hopefully. Yeah, so it's this red path right here. So Florent Michaud modeled this path, which he actually modeled a much more precise path. I sort of just drew in a path, sort of mimicking what his path was. And then what we did was we mounted a sphere that is about 15 inches in diameter. And all these figures we're not just guessing on these. These are precise figures. So the GPS figures let us get to precise places on the map itself, and then measurements of objects and so forth. Those are precise as well. So that I put this little sphere, 15-inch sphere, and I think you might be able to see it moving along. It's right there right now. And it's just following along the path. What you're seeing here is the line of sight and the field of view from the camera itself. So in the beginning of the video, the camera has sort of a wide angle, and then there's a point where it zooms in. You see that right here. So that tells you where the camera is looking, and then our little ball is just following right along. It turned out that by modeling the ball coming from here to here, that it was going about 18 or 19 miles an hour, and which happens to be the speed of the wind at 245 meters, which is where the ball is positioned in the sky. The ball starts out at 245 meters in the sky, and it just follows along at a constant speed along this path. Now, the cool thing, of course, is that you can look through the camera that's mounted where the plane is. And so this is what the camera was seeing in the plane. And there's the little ball, and it's just following along the path. Now, let's see, what else did I want to mention here? Oh yes, I wanted to show you the keyframes that were used in the simulation. Now, so keyframes, basically, that would be how, if I were going to cheat this, I would cheat it by making a keyframe that moved the camera to a different place, or that moved the ball itself to a different place. So I did have to make a few adjustments during the course of the video we made. I had to make, basically I told the ball to start here, and at the end of the video it was at 100%, so I started at 0% here and went to 100% at the end of the video, just following along the path that we made. But it turned out that on a few occasions it left frame. So I made a couple of adjustments during the course of the video, and you see them here. I made 3 adjustments here, here, and here. And there you see the 0% and the 100%. Those adjustments that I made amounted to less than 1% of the entire video. And over the course of the entire video, I changed it by about 2 or maybe 3%. So we felt like that was a fair amount to change, to make the model follow the position we wanted. Just because we're figuring that wind is not necessarily a completely constant thing. And so a 2% change seems very minor. Additionally, the other place that I added keyframes is here, and what that is the altitude of the object. We started it at 245 meters, and by the end of the video it drops down by about 20 meters. Again, we felt like that was a very fair amount. All of these other keyframes that you see up here, those are all related to changing the altitude of the plane. And that I did by hand, but I did it using the data in the video. So I just, wherever I think I did it maybe every 10 seconds, I changed the altitude of the plane to match the data that we see also in the video. So the main thing I'm trying to stress is that there aren't that many ways to cheat this idea. The pathway, was postulated by us, but we didn't know if it was going to work, if it was going to look just like the video. It turns out that it does. It looks so close to the video that it's really amazing. So that we're quite confident in saying that a balloon easily fits what's seen in the video. Now, there's one other thing I ought to mention. Our simulation ends at the point where the object gets to the water. And the reason we ended it then was because the GPS that we have for LOS is very, very inaccurate. It's off by up to 300 feet at times, maybe more. So that the LOS, the line of sight data, had to be corrected. And I was able to correct it and have some degree of confidence that I'd done it, that I'd properly done that, because I had landmarks from the actual ground to tell if I had done that. So every second I corrected so that our simulation matched what was being seen in the video itself. So if you can go through yourself and compare what we did every single second and see if it seems to match, and hopefully you'll see that we took a lot of care to be sure that our simulation matches what's seen in the video. But when we get to the water, there are no landmarks. So although it would be easy to go through and just make the thing work, because who knows where, would we know where the LOS was, since the data is so unreliable. So I could have made it work, but it seemed unfair to do so. I would just be really cheating. We did model all the data anyway, and so we do know that in the end of the video, the place, when it did get to the water, it still was looking precisely where we would have expected it to be looking had we continued the simulation further. So in other words, our simulation ends right about here, but then the plane continues and is just looking right down here. So all that stuff seems to work, and we think we've proved our point anyway. So I hope this helps, and talk to you later. Thanks.